point to another. For instance, in this case, it flows all the way from the national grid. This is the setup of a meter box, and then it goes all the way to the consumer unit. Why? We will be explaining that in a few. But the consumer unit is definitely the heart of any electrical installation. And now from there, we have several circuits. These circuits have MCBs. The MCBs are for various circuits. For instance, we have a 32 ampere circuit and breaker. Then we have 20. We have 16 and a 6. Each of those are for specific circuits. For instance, we have the cooker circuit. We have heaters such as the instant shower head, and very important, we also have this circuit for lighting. Today's live stream focuses on this connection here. Why am I interested in this connection is because we have two power cables here or power lines. But in any electrical installation, we must have another one which is very, very important. Its color is this one, yellow with green stripes or green with yellow stripes. My top boss, let me know, what do you think about having that in a lighting circuit? Remember, in a consumer unit, priority has been given. For instance, we have this bar here. You know, we can call it a bus bar or an earth bus bar. Remember, there is also another one here, and another one is also located at this particular point. All right, so we have two bus bars, then definitely the neutral. The only point where we have switching happening, whether it is an MCB or it is a switch, we have it on the face or the line. Normally, in what we have in the switch, you have L. So L is definitely line. Good to see you. Bernard Odanga says hello. Thank you so much for tuning in. I also have Elfas Kimurgor. Good job live from Kapsabet. Means a lot to have you joining me, my top boss. So that is what we are going to discuss. We also are going to focus on something that is very, very important in the life of an electrical technician, which is troubleshooting. In case we have issues in our circuit, for instance, we have a circuit scenario whereby we have a phase, you know, being available, and we definitely require what is a return path of electricity, the neutral. How does that circuit behave? You know, if you only have presence of a phase and then the neutral is missing, how does the circuit behave? Alexander Ephraim, good to see you. Say excellent. Thank you so much for your presence here. I also have Kip Korir Dennis says, hello, Top Heights. Is a double pole MCB unidirectional? We are going to also talk about that. And we'll be able to know, you know, can you connect it probably from the bottom or from the top? Or can you interchange and have the live connection flowing on this side, the left, as well as the right? Is it unidirectional? Dennis wants to know that, and we'll definitely be covering it. I will also be taking you through the problems that are associated with connections or terminations. What happens in case there is a loose connection in any electrical circuit? Electrical or electricity flows in a loop, and therefore, if at all there is a loose connection in that loop, what do we expect? What happens, right? Some of the things that we expect to see in an electrical flow that has a problem. What are those? We're going to talk about those. We are also going to highlight the best way to, you know, combat such issues, you know. So that means in case there is a fault or in case there is a problem, how do you deal with that? All right, my top boss, that is definitely what we are going to talk about. And if you are geared up for our today's session, you want to learn a lot, my top boss, kindly smash that like button and let me know where you are streaming from. So I'm going to use my board here. Me loud and clear, my top boss, I will really appreciate that. So what are you seeing on my board? What are you familiar with? You know, right there from the consumer unit all the way. What are you familiar with, my top boss? We also have the socket connection right there. I'll be able to talk about that. What type of a connection is that? Again, my top boss, I was in my last YouTube video that I did, I was able to highlight that. I did a lot when it comes to that connection, right? So we are still going to talk about that. And some of the tools that I will be using, I'm also going to share about them. I have screwdrivers here, very important screwdrivers, insulated all the way. You know, as I was beginning, I would come here with mechanical screwdrivers, and you, top bosses, would really put me to task on why I was not using the correct tools. And that is why I had to go back to the drawing board, rethink about my life, rethink about my career, and came with these important tools, the screwdrivers. I also have this tester, right? So we are going to definitely have a great time, my top boss. Let me start with this light wiring connection. This is the elephant in the room. Today, this is the elephant in the room. I don't know whether we can say it that way, the elephant in the room. I think it is a radio connection for the sockets. That is from our top boss, Kip Korir Dennis. Wow, wow. Absolutely. Because you see, it is coming from the consumer unit through this conduit installation or conduit layout all the way to the first socket that is right here. And then it is connecting to this other socket. And that's it. That's it. You know? And if at all it was definitely a ring circuit, we would expect from the consumer unit, it goes to the first socket, the second socket, and then back to the consumer unit. Such kind of wiring in the socket installation or even in the light is referred to as a ring. You know, it forms a loop. And we normally say that when it comes to electrical, we have a loop sort of thing, you know, a loop sort of formation whereby electricity flows from a starting point. And by the way, if you grasp this concept, it will be so easy for you to even troubleshoot as well as come up with the right circuits for whatever projects that you have. Maybe it is a school project or it is a project that you are undertaking in the field with on your customer's project. So assuming this is the transformer, electricity will have to flow all the way back. So anything that you place on this loop definitely has to have that return path. So if you interrupt this loop and place a bulb, the bulb will light simply because the current is flowing into the bulb and then back to the transformer current. All right. So anything that you place inside of this loop, be it an MCB, it is supposed to be tightly done. You know, it is supposed to ensure that that flow of current is constant. It is not interrupted. So you can have an appliance, you can have you know, a device, a gadget, can have something like a bulb, can have, let's say, a charger placed in that loop. You can also have a safety device placed in that loop for various reasons. Like, let's say you can have this important device here, you know, that has that small orange button. That one. This one. So it is also placed in the loop. So the purpose of this is to do what? What is the name? What is the purpose? Morgan Wizu, good to see you. Say, good work, teacher. Thank you so much. Matthew Shola, Harmony, Rajo, thank you so much, all my top bosses, for joining in. It means a lot to see you. Thank you also for the likes. I see you. And even if you'll be streaming or watching this stream on recorded version, I really do appreciate you. And I would also want to know where you are streaming from, where you are watching us from. My name is John Gatehi, and this is Top Heights Electricals and Electricians. You are my top boss, and I always appreciate when you join me. My top bosses from Kenya. Immense support and immense love from you, my top bosses. I really do appreciate. I also have my top bosses from Ghana, Uganda, Nigeria comes in with a lot of love, not forgetting Zambia, South Africa, UK, USA. Europe is in the building, and I also appreciate the love that I get from my brothers in Somalia, in South Sudan. It means a lot, my top bosses. So let us get into it. On this particular lighting, let us first of all get rid of this bulb. And my concern here is that we have two lines. Now these lines are the face or the line as well as the neutral. The biggest question is this: do you require earth connection in the lighting system? I have encountered a lot of people asking me that question. Now, today, we will be able to get to the bottom of things. First of all, remember, for you to be an electrical technician, you must have to go through the schooling or the education system. Number two, very important, is licensing. You have to be licensed. Now, licensing protects the consumers or your customers from other mediocre people, assuming that people who are here are electrical technicians, electrical engineers, or are studying or are artisans. Now, it protects you from anyone. It protects the customer from anyone who claims that, you know what, I can do this work. So if at all you are licensed as an electrical technician, it means that you know what you are doing, you know what you are up to, you know what is supposed to be done. For instance, any other person that is executing electrical installation in many cases will assume that, you only need to have power flowing from point A to point B. There are factors, important factors that you need to factor in when you are conducting an electrical work. For instance, resistance. That is another area that so many people have a challenge. Another indication that you will know that this person does not understand much about electrical installation is the fact that they will not factor in resistance. And how does the resistance come to play? It comes to play in this sense: the choice of the size of cables. Harmony Rajo says, nice one, napenda your job. Thank you so much, nice. Karibu sana. For my non-Swahili speaking top bosses, napenda your job. Napenda means I love. And when I say karibu sana, I say you're welcome. Thank you. Thank you so much, Harmony Rajo, for that. So, in this lighting setup, my top bosses, as the name suggests, it is light. Probably taken literally, it is lighter. It's light. So the size of the cable is smaller. This is a 1.5 mm cable. Now, if someone decides to use a 1.5 for socket installation, and they are very comfortable about it, what are the hazards that we must foresee coming? Someone decides, you know what, I want to use a 1.5 cable for socket wiring. For instance, we have sockets here. We have used 2.5. So someone decides, you know what, I'm going to use 1.5. What is the hazard in there? All right, let me know. Let me know. Answer my top bosses. Titus Skipper says, following from Meru, I really love your lessons. Titus, thank you so much, my top boss, for that. What a wonderful name. And so glad to have you joining me in this stream. All right. Yes. Now, do you incorporate earthing in your lighting wiring? This is a 1.5 mm cable. Look at that. Is it made of pure copper? Only tests can prove that. 1.5 from the consumer unit, it has to go all the way, through that circuit. So look at this shoddy work that is here. Tape, going to get rid of this. In fact, here we were not supposed to have any electrical joints. Shoddy work right there, John. But assuming when wiring this board, we had other connections, like let's say a two-way connection. So we leave it at that. We leave the joints at that. So this cable travels all the way. The reason why I'm finding it easier, to insert this cable inside here is simply because I don't have a lot of cables going through. But again, remember, if I had a lot of cables through this conduit, I would have to get rid of all of them and then rewire once more. Just like that. So what is the reason for an earth connection in a circuit, a lighting circuit, when you only have this type of light? You have this bulb, for instance, which is common in our today's world. So you have this terminal as well as this one. What happens also in the bulb holder, which is very, very important for me to show you, is that the bulb holders themselves come with only two connections. Most of them come with two connections. I will also be demonstrating to you other bulb holders that come with several connections apart from, I mean, just two. I mean, three. You have two. So a very good example of a lighting fixture here is this. It is so common. I don't know what you refer to in your country. This one. What name do you give it? Talk boss. Let me just get this paper off. So this one, as you can see, it has two cables or two wires in that single cable. So you have the red, you have the brown and the blue. How it found itself in this country, I don't know, because in our country we are familiar with red and black and green with yellow stripes. Those are the three common color codes that we use. What are color codes? How important are colors when it comes to electrical installation? So you see, there's a provision here to this point. We have the L or line, we have the neutral. This one here is reserved for earth connection. Really? No, loop. This one is indicated loop. Earth connection is reserved for this part. But as you can see, the manufacturers of these bulb or lighting feature here have only given a provision for two. Let us see at this point. That is what we are seeing also. Only two. What they had in mind is this type of bulb connection where they will only be interested with this connection here. So the manufacturers are also defecting on their products Now, which one is defective here? Is it the bulb or is it this one? Cool. Let us get further to another important point or another important thing that I would like to show you, which is this one. What is the correct name given to this? So let us say this one is number 1. On the comment section, tell me number 1, give it the correct name as per your country. I really appreciate. Number 2, what is the correct name as per your country, my top boss? Look at that. It's interesting. And finally, number 3, last but not least, this one. What is the correct name as per your country naming of electrical features or fittings? Top boss, let us engage on the comment section. I will really appreciate. We have number 1, number 2, number 3. Let me see whether you are very keen in our today's session. This is the new class. Forget about the class that we were used to. This is very, very interesting because things are live. We say that this is number 1. What is the correct name that you give it in your country? Normally, when you install it, this is how it appears. What is the correct name according to your country? Number 2, comment number 2 and give it a name in your country. The correct name. First of all, there is something guiding. When you look closely inside, there is something that can guide you. That is number 2. Give it the correct name as per your country. All right. And finally, my top boss, number 3. This one. This is the third one. Now, very interesting that I would like to bring to your attention is that these two have some difference. This one, see this, as well as this one. This one has a blue stripe here. This one, pure white. They look similar from outside. There's no much difference when you look at that point. But again, the difference comes in here. That is a huge difference. If, for instance, you have ordered for the materials, you are in the construction site, and you are looking for specifics because of the lighting fixtures that you also have. The difference is this, right? One can be fitted with this type of bulb connection here, all right? I don't know whether I have the other type of bulb here. I think I have it, but it's, let me see. It's somewhere. I will have to get it, but yeah. So this one is a screw type bulb that is supposed to fit in there. And then this one is a pin type bulb that is supposed to fit there. Titus Keeper says one is ceiling rose. Absolutely correct. Correct. Can see how proactive you are, Titus Keeper. Thank you so much for that feedback. Appreciate it. Kennedy Opio, good to see you. Jamal Diad, good to see you as well. Thank you. Thank you so much. All right. So I go back to the question. Do you think with this type of lighting feature here or bulb, is earthing important? That is the main question for our today's stream. When it gets to wiring standard, the correct standard is this, where these are the important features that you have here, right? Look at that. They are 3. Y can connect the line here, neutral, and earth connection right there. How will you know? Maybe it is indicated. If not, then you will have to go the tedious way of using that uh, instrument, which is referred to as a digital multimeter, to test for continuity. Why continuity? Continuity will help you to know what port or what pin is connected to where, right? So taking these so this is at this point we have to definitely put on the meter by simply tapping on this. I have to put it on like that. All right. And so the best thing for you to do is to test whether your meter is working. You simply take the probes, you know, and place them on each other like that. You hear that beeping sound, it means there's a continuity. You also move from 1 to zeros, meaning the resistance is 0. So you see 1 is definitely indicating infinity. See, like like you are recording nothing, so infinity. But again, when you do that way, that is a connection that is made, so it's like a short circuit of the probes, and that is what gives you the continuity test. We can also use this cable here just so that I can be able to clearly demonstrate to you. So using this cable or this wire, assuming we want to test whether it is continuing, let's say we have this joint here. We want to know, is this wire continuing, or is it faulty, or is it broken inside? So we simply place on one end and then on the other end. So you hear that beeping sound, and it moves from 1, infinity, to 0. If there is some uh, indication at this point or some figures, you'll know that there is resistance, and therefore you must know, what am I expecting? And so the figures here will definitely be guiding you. All right. Okay. So let this meter be here, because we are really going to find a lot of application with it. Okay. Or I can simply move it at this point. And then I will progress with my connection all the way. Okay. So for me to avoid any issue in here, I will simply push, there we have it. Okay. So normally when you are wiring, you have to normalize these loops. See how the loop is appearing there. So, and then I will definitely need to do something with this connection that I have. When it comes to tools, it's important to have the right tools as well as know their names. This one is a side cutter. Side cutter. So we are using it to cut. So why am I leaving a lot of provision for this cable here? The answer is simple: for future maintenance work. Okay, future maintenance. So at this point, I have to get rid of these tips that I had earlier on used. So So from the consumer unit, this is the first junction box. Look at how bad that work looks. But again, there is something that I think I wanted to demonstrate, which is color coding. So I used a red tape for that, and then I used a black tape for the black cable there. Now, the tightness or how tight the cable is means a lot. It is very important for you to ensure the connection is very tight. Okay, just like how I had done with that red connection right there. So look at that, very tight connection. So to avoid puncturing the tapes, I will simply cut the tip of the wire, which looks like it's very sharp. So I can either decide to do tapes, or I can use these connectors. What is the correct name for these connectors? Top boss. What name do you give to those connectors? Have you ever come across them? Do you use them? Probably as you are working in your construction sites, do you use those connectors? So I will also be demonstrating something that is very, very important about these connectors here. I have a response from my top bosses, Moses K. Wangaruro. Good to see you, Moses. You say WAGO connectors. Michael Chukwedu said hi. Abu, good to see you. Zakaria is in the building watching. Thank you so much. So what is the name given to this type of connectors? Fidel Castro, what an amazing name. Top bosses. Did you finalize on inverter connection? Because I did not see how to connect the inverter from the national grid. All right, good question. I didn't. I will connect. I will be sharing a video on that, and I know you've definitely subscribed, but I will be sharing a video on that, my top boss. All right. So these are WAGO connectors. Let me simply connect them. So when it comes to these cables, like I said, due to a lot of cutting, it is good for you to always leave an allowance. So that is why you can see from my box, there is that allowance. All right. Now we need to apply the correct tools when it comes to electrical. So a side cutter is so good at cutting, but when it comes to stripping, you use this stripping tool. What is the correct name for that? Of course, it is a cable stripping tool. It comes in handy when you have to do a proper job, and that is definitely stripping. Stripping cables. So with this, I'm able to strip cables of very many sizes, all the way from 1.5 or 1.0, such as this one. See, it's very fast. So we are moving away from using insulation tapes and twisting wires, to ensuring that we do such a speedy job. For instance, what we are doing here, you see, stripping is very easy, very safe, and we are done. Now we have WAGO connectors, as our top boss has rightly put it. There are connectors here. For instance, this one is a 3-in-1. So for this type of connection at this point, I only need to use a WAGO connector that is incoming and outgoing. See? So this section here is continuing with this section. If you want to prove it, let me show it to you. And you see, when you're using WAGO connectors, it is also important for you to always use a digital multimeter for testing. So for this WAGO connector here, this point here is continuing with this point up here. See? And if I try to loop it on the other, to test on the other side, there is nothing. It is not continuing, or what is the correct term? So if I select the center as well as connect the probe on the center on top, it's continuing. If I select that, it is continuing. So I can decide to use this only one, or I can use these ones, 3 of them. Now for these ones, you need to also understand that they are both continuing at this point and at this point. So if you want to join 2 cables, you insert the incoming here, the outgoing here. So I will need to have 3 of them, that point. So see that? Continuing. That is how you test for continuity. So I can either use 3 of these, or I can comfortably have 1 here. But again, I don't know whether this size is, I don't know whether I will be able to achieve that with this space that is here. Okay. I foresee having a lot of issues having 1 of these here than having 3. You see, like for instance, for this case, I only have 2 and there is plenty of room. So I suggest that I connect these smaller ones here, the single WAGO connectors, so that I may be able to have enough room inside there. There's also another set of WAGO connectors. This one accommodates 4 connections. Incoming, the incoming one, and then if you have 3 other connections that you need to connect right there, right? But for this case, let us apply what we need at the moment. So I have decided to go with the single connectors. So for the single connectors, what happens? You take, for instance, earthing. All you need to do is to lift this lever, then insert inside, and then you clip. Very simple. First of all, you need to ensure that your wires are straight. Okay. The other one is like so. So even for this line, just ensure it is straight. For the neutral as well, all of them have to be straight. So for earth connection, I will simply insert it in, clip, insert it in, and clip. Very fast, no? And it goes to the neutral. We'll do the same. I'll take another WAGO connector, lift the levers, then insert the neutral, first neutral, second neutral, clip like so. Remaining with the line, insert it here, clip, then this one, clip. Look at that, very neat. The next time that I want to do repair work or get rid of them, it will also be simple. Let me demonstrate using that. Look at that, very fast. If I want to join them again, simply clip them in. This one, clip them in, very fast, right? It makes work to be very neat, very fast. Now, I need to get the cables right in. So, forgive me for twisting these wires in a very inappropriate manner. But again, I'm creating room for future maintenance work that way. Then I can have this one on top of that. That is what we have. Makes sense? So I have the connections. It is hard for you to, it's hard for them to puncture each other or, get in contact with each other. Once I have done that, very important, especially if this is a connection that is in the ceiling, my top boss, it is very important for you to take note that you need to cover that up. Okay. So you cover that connection up with this circular cover. The reason why is to avoid invasion of rodents. Rodents may eat up this insulation. They love eating this insulation. When the insulation is exposed, it means that it may short circuit, bringing a lot of trouble to the installation. All right. So with that screw, I will simply have to screw it up. So whenever you are quoting for your customers' electrical work, ensure that all of these items you quote them. Don't be that ancient electrician who quotes insulation tapes. Well, insulation tapes are important, especially when it comes to color coding. And even with that, we also have the shrink sleeves. But there are cases whereby you will definitely require an insulation tape. But for this case, especially when it comes to, making electrical connections or joints such as this one in the ceiling, or joints that will be in the slab, ensure that you definitely use the WAGO connectors. At least at the moment, WAGO connectors are so good. Okay. So you need another screw right there. But for demonstration purposes, let us progress. Now, at this point, we have the neutral and the line or the live connection. The reason why I will not have to cut this and connect, that WAGO connector here is simply because we don't have a circuit that we are introducing here. But in future, we can introduce a light point at this point here, and therefore we will definitely need to cut this earth cable and then connect or loop at that point. So in the meantime, I will simply have the cable get in like that, and then I will cover it. I'll cover it with a circular cover. Sylvester Dash, how are you? Good to see you. Ishmael Charo, good to see you. Yeah. Fidel Castro says, while using the WAGO connectors, can an electrical engineer backfold the strands? No, don't backfold the strands. Just connect, strip and then connect. George Onyango, good to see you. Say hello, my great teacher. Hello to you too, George. Samuel Sakei says hi. Hi to Samuel, and you say you are watching from Dubai. Thank you. Thank you so much for tuning in. Sophie Kerubo, we are now back. New member here. The wiring is about. Is that a question, Sophie? Don't know. The elephant in the room, Sophie, probably if that is the question, is are we supposed to include earth connection when it comes to lighting? Where in our day we have a lot of lighting fixtures that only come with two connections, the most common one, which is the line or the face as well as the neutral. And I would suggest yes. In case your customer decides to change the lighting fixture, there are so many cases whereby I've had to change this type of connection or this bulb into a lighting fixture that has a connection for earth connection. For instance, there are chandeliers that require earth connection or earth termination, or there are lighting fixtures that have metallic fixtures with them. Therefore, you are supposed to include or to wire the earth connection. Does that mean that you'll have to rewire the house again? So it is better for you to include whether the customer purchases a product that does not have the earth connection or not, but being on the safe side, as well as remember, it is good to follow electrical codes. All right, electrical codes that we learned, or the ones that are existing, or the ones that have been updated. Ensure that you do the right thing. Earthing connection is vital. It is very, very important. Ishmael Charo says, nilikuwa nauliza uko na shule yako binafsi? Hapana. We are just here online. Sophie says, just joined right now. All right, you are very much welcome. Sylvester Taj says, my expertise have joined right now, have installed the heater switch. Awesome, awesome. You are not installing the heater. We did it in a previous video, and you can learn a lot from that. But today we are talking about the earth connection in the lighting fixture. When it comes to this point here, what I have with my bulb holder is this, very important. So let me just first of all get rid of this point here so that I can be able to show you clearly. So where are you streaming from, my top boss? And I thank you so much for tuning in. When you take a closer look at this holder, don't know whether I can be able to, all right, yes. So when you take a closer look on that holder, what you can see is we have the N, this is the N, and then we have the L, and then we have the E at the top here. What does that E stand for? Or what does it mean? Is it clear from your end, top bosses? PST Moses Lawi, or MLO, says, great work, Top Heights Electricians. Thank you so much. Is PST for pastor? Sophie Kerubo says, stands for earthing. Absolutely correct. Ahmed Amadou, good to see you. You are from Qatar. Hi to you, my top boss. Yes. So you see, with such a bulb holder, it indicates that the manufacturer knows what they were doing. All right. And so they included that. So we will simply go ahead with our stripped cable and connect in there. Make sure that Cable is all in, I mean the wire, and go ahead and tighten the screw, right? So we have our N intact, we have our L intact. And now we want to know, probably you are curious like myself, you know, we have these two pins inside here, and then we have this metallic case, you know. So we want to know from what we have here, do they live up to their promise? The best thing to do is to use a continuity test. So with my meter right in place, just ensure that I adjust so that you can be able to have a clear view, my top boss. So if I may take another, you know, if I have this, let's say I have this earth connection. So I'm assuming that with my bulb, what they have factored in with this type of connection or with this holder, this metallic case here is the earth connection, which is in contact with this. Because you see, if you insert the bulb like that, this metallic part, even these pins here, are in contact with this metallic part. So we're assuming that is the earth connection, BSEN, okay? And then for these two pins here, which is common sense, is L and N, line and neutral, which gets to this point here, L and N, that is required to energize this bulb. The other part is earth connection, which is for safety. So let us test it. So we, when taking any readings, or when troubleshooting, you are supposed to know what you expect. So we expect continuity. So we have set our digital multimeter pointer here at continuity. And so if anything is continuing, we expect that. We expect it to move from 1 infinity to a figure. And then the figure that we are expecting should not be more than 1 ohm. I don't know whether I'm saying it correctly. Anyway, I hope you get my point. So if at all the meter gives that beeping sound and a very low resistance such as that one, you know, or if you can place it at 200 ohm, then place the probe, place the probes together. Very low resistance right there, very low. I think I need to also charge the battery of that multimeter. You see? So if I get a beeping sound when I place one probe on this section here and on this earth connection, definitely it is continuing, so that is the correct. If I place a probe on this earth connection here, or this metallic, and then place the other probe on the neutral, I expect a 1, meaning they are not short circuiting or not continuing. If I do the same for line, it is a 1, or simply put, it is infinity. There's no continuity, which is the correct one. Now, when we get to the pins inside, if I place here on one pin, one of the pins right there, it's so difficult, to just balance. I try, and then place on the neutral, or either the neutral or the line. So this one indicates that this one is the neutral. And then I place on this other pin here one probe, and then on this part here I place on L, or yes, the line. What's happening? Getting bigger figures, huge figures right there. Seems there's some rust somewhere. Supposed to get a beeping sound. There we go. Yes. So it means that this pin and the line are continuing, this other pin and the neutral are continuing. And so we are good to go. Now, having done that, The elephant that was in the room is no longer an elephant, because we have said that indeed we need to include earth connection when it comes to wiring, wiring of lights. So that is what we have right there. So you'll simply connect our bulb holder. Another thing to do is to ensure that you understand the bulb holder correctly. You see these notches here have to pass through this notch here. See that so that it will become easier for you to connect. You see that one there. And so you take this, then you simply screw, like that. Sure that you reorganize the cables inside. There is plenty of room for those cables. Why? For future repairs. Again, I will mention a lot of that here, so that you know that just because you have concluded on that electrical installation doesn't mean that you will not get back there. You'll definitely get back there, because you have to do electrical maintenance work. Even though it might not be you, it probably can be a different person, and therefore you must leave that room for future repair work. Okay, you just go ahead and screw it. You have to screw even the other part, and therefore after you are done, simply insert that right there. Okay, and then insert that bulb right there. And then very, very important, having wired our earth connection, we definitely need to conclude on that work on the consumer unit, because even if you have connected all the other sections of the the circuit, and yet you have not wired at the consumer unit, that is zero work. The circuit is still not earthed. That is why we will have to take this wire right here and strip it. See that? Stripping it, we'll then do a very important thing, which is connecting it to the bar, the earth bar. But again, you need to backfold it so that we can have plenty of room for contact. So you see the way it is. Then using our well insulated screwdriver, we'll definitely unscrew at this point. Connecting earth connection for lighting, and then pass it all the way through the corner. So I've used a longer route so that you can have plenty of room for repair in future as well. So can we test the circuit, test the work that we have done, put it on? That is the best way that we can do. But before we put it on, we just have to ensure that we also take our digital multimeter, because we were working on the lighting. Assuming that other areas were okay, we now test the work that we have done on the lighting. So the best thing to do is to also go for continuity test. So we have installed the light earthing right there. So the worst thing that can happen is to have a short circuit between the earthing and the line or the face. Another thing that could happen is to have connection between the neutral and the earthing. That is faulty. Another thing is the neutral and the line or the face. That could trip the MCB because that's a short circuit. If we get that beeping sound and those figures on the screen, it definitely means there is a short circuit. So you start with the line and the earth. It is 1 on the digital multimeter, meaning that is infinity. So there is no continuity, no short circuit. Between the neutral bar and the earth bar, we expect a 1, no continuity, only infinity, which is okay. Between the neutral and the line or the face, we definitely expect open circuit, right? Sometimes you may get figures if at all there are some appliances that are on or a light is on. So can we test the circuit and have the bulb come on, right? So I'll simply activate my circuit. So I have to first of all activate the meter, switch it on, the meter is on, and our circuit is off until we activate the consumer unit by simply switching on the isolator. That one. Already some of the circuits are already turning on, like the cooker. This one on for the instant shower head. It's turning on. Okay. How about our lights that we have worked on? Right, it's working. Things are great right there. Okay. So my top boss, that's it for today. In many cases, you find that most electricians don't want to include the earthing connection in their wiring, but it is very, very vital, very important in case the customer decides that they are not going to use this type of bulb, but they will use another lighting fixture. So to be on the safe side, even if you will not be the one that will come back to do that work, kindly ensure that this earth connection is included in your wiring, so that even if there is the need for someone to replace the light, whatever light they will have, it has to have that connection for the earthing. Yeah. How many types of consumer units do we have regarding to the size? That is Fidel Castro. We have 4-way, we have 6-way, we have 10-way and 12-way and so on and so forth, right? A great question from Blink says, what is the difference between polarity test and continuity test? Polarity test in most cases applies when it comes to DC, direct current, where you will need to determine which one is the positive and which one is the negative. When it comes to AC, we have line as well as neutral. Now, how to test for line or the positive? You definitely will find that on the digital multimeter, you have that positive and you have that, negative indication on the meter, on the screen. But we will do a whole video or a whole stream on the polarity test or the tests that we can carry using our digital multimeter, which is very, very important. So continuity test simply ensures that you see from this point here to this point, that wire is not broken. In case the conductor is subjected to the flow of current or it is in an electrical circuit, we will be sure that if the wire is continuing or if we are carrying the continuity test and the conductor is continuing, definitely electrons will be able to flow through. All right. So I think I've answered most of your questions, but if you have more questions, kindly feel free to ask in the comment section. This live stream is definitely going to live here on YouTube, and we will be able to interact even after the stream. And if you are joining in as watching as a recorded version, Top Boss, comment on anything that you would want me to, give it my attention and my time, and I will be glad to do so. Thank you so much for my top bosses who have been watching the stream. And if you have learned a thing or two, or if you have refreshed yourself, smash on that like button, and I will definitely know. If you have any comment that you would want to put across my top boss, let me know in the comment section, and I will really, really do appreciate. So thank you so much, my top bosses, for your time. It has been great. That has been my time. My name is John Gatehi, and this is Top Heights Electricals and Electricians. It was quite a pleasure having your attention. I can see Zachariah Matsoso says, what would the size of the wire be from the main supply to the distribution board? 10 or 6 mm, depending on the wiring that is being conducted right there. Blink says thanks. Thank you too for your time, Blinks. Del Castro, it was a great honor having you. Sophie Kerubo, thank you so much for joining in. Sylvester Tash was here. I appreciate your time. Ahmed Amadou says hi. Thank you so much, Ahmed. Titus Keeper was here. Thank you so much, Pastor Moses. It was an honor. Thank you so much. It was great having you, Ishmael, as well. Thank you so much, Jojo Nyango. Thank you so much. It really means a lot when you join my stream. Moses Wangaruro, Michael Cheku Edu, Abu Mukangai, and Zachariah. Thank you so much, all of you, my top bosses, for watching and always interacting with my content whenever I share it. You being a subscriber, interacting with my content by commenting, by liking my videos, I really do appreciate all of you, and also those who share. It means a lot. If you have not subscribed to my channel, kindly subscribe, and it means a lot, my top boss, when I walk this journey with you. We started from 0, we went all the way to 66 subscribers for quite some time. We shoot to 500, all the way to 1,000, and here we are, almost 50,000 subscribers as of today. This is 7th day of July 2025, and we are looking forward to grow very, very much. But most importantly is for you to get that knowledge. And if you are a beginner electrician, you are my main target. I always look forward to ensure that I help you become a better electrician, my top boss. And if you are an experienced one, ensure that you also light another person's path. Thank you so much, my top bosses, for your time. Goodbye for now. Sophie Kerubo, good question. You are asking what time my streams are on a daily basis. I've not scheduled them, but I will be scheduling them very, very soon. So just keep here, right? So in a very short while, I'll definitely be releasing that schedule so that we can be able to understand the schedule, all right? And also be tuning in together so you can see the cooker socket is on, the instant shower head is on, the lighting, I've done the lighting, and it is definitely powering on, right? Our sockets are also doing well because from the MCB here, everything is looking great. Thank you so much, my top bosses, for your time. See you in the next one.